Hello, everyone. My name is Xinshu. I'm partner at IOSG Ventures. Today, we have Alex from MatterLabs with us. So it's our great opportunity to hear him sharing some of thoughts about scalability. And today, we are going to have a change of format. So instead of a monologue from Alex presenting the project, we're going to turn it into a dialogue where I'm going to ask some of the questions that I'm fascinated about. Then towards the end, we'll also pick some of the questions from the developers in this hackathon. So for those of you who are not aware, this is part of the programs from the Layer2 hackathon we are co-hosting with Chainlink. IOSG Ventures is an early stage venture fund. We work very closely with early stage projects, helping founders and developers build their projects along the way. So without further ado, let's just get into some of these questions. I think we all know Alex, we all know MatterLabs. So to me, Ziksync is a great piece of technology. It has everything we want, scalability, security, decentralization. And with the recent introduction and launch of Ziksync, now we even have great programmability as well. So this is something that sounds very futuristic, except that it's ready now, today. Alex, share a little more about the secret sauce behind how is this even possible?
Sure. So first of all, thank you for having me. It's an honor to present here. So Ziksync is indeed it's built on zero knowledge proofs, and they are considered kind of magic technology because they really solve a lot of problems in very interesting ways that was not possible before them. So Ziksync version 2 with EVM compatibility is not quite ready. It's still in the works, and we will open the public testnet very soon. And it will still take some while to make it mature and ready for production. But it's here, yes. So like the technology is, the components are available, and it's a matter of pure engineering to complete them. And I'd say that why it solves so many problems in a seemingly easy way is because a lot of thought was put specifically into making this technology very user-friendly or developer-friendly, because the developers are our users. So we actually architected it in such a way as to make it as seamless as possible for existing projects to migrate. Without this deliberate thinking, it would not be possible. If we just took the technology and shaped it the way that is more suitable for technology, we would probably had a lot more rough edges. But we deliberately designed the system with the ease of migration inside. Like this was the first priority for us.
Yeah, that's great.
I will also
Yeah, maybe you can just share a little more on how can you make this even happen from let's say the platform perspective. This key cornerstone of ZK based validity proof. How does that fit into the bigger picture? How does that make all these desirable features possible?
So well, we had a couple of videos about this, which explain it in detail, but I'll just quickly say that the key innovation which made it possible is recursive proof composition. And this allows us to have different types of transactions with different execution traces to be combined together in one big block. And then we can prove the execution of this one big block with Ethereum compatible virtual machine, like aggregated and proven to Ethereum as one single proof. So this was the key technology. Once the recursion became available last year, the rest became a matter of engineering, just like gradually adding one by one pieces to make this composition practical.
Yeah, that sounds really fantastic. And I think the beauty of a technology like Ziksync is that, on the one hand, you have very sophisticated mathematics governing, the security of it. But on the other hand, you have made it very user-friendly and developer-friendly. So people don't have to know every single bit of it to actually leverage it and harness the power of it, right? I think if you imagine, like we basically have this, very scalable, very fast and secure platform to run applications. We might have, like, at least conceptually speaking, we might have two approaches in interacting with today's DApps, basically smart contracts. One is that you could consider migrating the smart contracts from layer 1 to layer 2 through either rewriting, returning into Zinc, or through some compiler to compile Solidity into Zinc. That's one approach, basically migration. And after that, everything's done. You just work on layer 2. But there's another approach, which is that you could actually aggregate the users and assets in layer 2 and interact with the layer 1 contracts and DApps directly. That's the approach taken by some of the projects such as Aztec and layer 2 finance. So what are your personal thoughts on these two, pros and cons between these two approaches?
I really like the invention of this approach, and you can do interesting things. Like Aztec is building privacy application that lets user privately access DeFi this way. I think the major difference between the two, which will push everyone eventually towards embracing the native layer 2 functionality, is the user experience. User experience will suffer a lot if you're like adding it sort of from the side, because if you're aggregating transactions, that means the moment you make a transaction, it's not final. You have to wait for all the other users in the batch to also do their transaction, and then you need a lot of users who want to do a similar kind of operation. If you just want to swap, let's say some very rare token on Uniswap, then you have to wait for like a lot of these users who want to interact with exactly the same pair to justify this transaction, to make the batch, the costs of the batch amortized across all of them. And this will take time. This can take several hours. This can take days maybe before you collect enough users. Whereas when you have something natively in layer 2, when projects migrated, your transactions will confirm essentially instantly. So you will still have to wait for the finality, maybe like an hour to get this transaction final, but you will still have an instant confirmation with economic guarantee of inclusion in the block, and most users will just take that and they will be fine. If you're not receiving, let's say, millions of dollars, then this economic guarantee will be sufficient for you. And the user experience of just having something immediately confirmed is so great that like it will just provide a very important emotional feedback that will make users stick to this kind of solutions.
Got it.
But on the other hand, you also have economic advantages. Like if you have to wait longer, then the price may move, so you need to increase your slippage. And like the instant interaction is always a lot more efficient. So traders will prefer that, and the transactions for non-traders will also be a lot more profitable with low latency.
Right. Yeah, I guess there's some trade-off there. As you mentioned, in terms of latency, in terms of maybe certain kinds of DeFi applications are more suitable to one or another, right? If you are too sensitive to price movements, volatility, then probably you'll have to migrate your application into layer 2 and just run it there. Speaking of running smart contracts or programming smart contracts on layer 2, since most of our audience are from the development background, I guess. So can you just share a little more on your personal thoughts between the Ziggy languages? We have Zinc, we have Cairo, we have Noah. What are your thoughts? How developers can best choose which is the most suitable ZK language for them to implement their applications?
So I would separate the zero-knowledge languages like Noir from languages like Solidity, Cairo, and Zinc that just are generic smart contract programmability languages where you build normal applications, something you would build for layer 1. Noir and like similar approaches are aimed at building private smart contracts, and they take an entirely different paradigm. You don't write your code with normal functions that just imperatively execute the code. You write predicates that work with commitments, and you have to wrap your head in a very different way. So let's put that aside. If you need to build private smart contracts, you will have to go for those languages and learn these paradigms and actually have to understand how these things work. If you just want to write scalable smart contracts for layer 2, don't need all of that. You can either take Solidity and write your code there, or take some new approaches such as Zinc, what we're building, or Cairo, and write your contracts in these languages. My advice would be, if you have an existing application for Ethereum, for layer 2, for layer 1 or layer 2, like maybe you're on Polygon, maybe you're just experimenting with layer 1, don't bother much. Just take the same Solidity code and you will be able to deploy it on Ziksync without modifications. Like, unless you use some very, very specific things like cryptography, everything should just work without modifications in your code. If you're planning a new application, you might benefit from the functional languages, more advanced languages like Rust, and Zinc is a subset of Rust. So it's just a better way to write your code. You have immutability out of box. You have functional properties. You have a lot of like, the syntax is nicer. It's easier to audit. It's harder to make arbitrary mistakes because the syntax is very safety oriented. And eventually we will support full Rust, because Zinc VM is actually based on LLVM compiler. So we will be able to take normal Rust code and transpile it into this virtual machine. So if you're writing something from scratch just for specific layer 2, such as Ziksync, you can take Zinc and build this code. Alternatively, if you maybe you have application written in you have some parts of code written in Rust which you want to reuse, this is also going to be a good benefit for you. But most users can just take Solidity.
So it sounds like the tool chain nowadays, is so good that Solidity is no longer a problem. You can convert Solidity, at least most of it, into running on Ziksync. So exactly. I read from the release note of V2 that there are a few corner cases, a few instructions are not fully supported yet, but I assume they can be substituted with other instructions. And then for SHA-3 K-check, it's replaced by something else, but eventually will be supported. Can you just share a little bit from the perspective that do developers have to have any considerations around these corner cases? Will there be any incompatibility issues, or there's really nothing for them to worry about?
Sure. So there are just a few areas which are not supported in the first release. They're coming later, but they're not just going to be part of the first release. The first class is cryptographic operations. This means modular operations, add mode, submode, mul mode, and calling of the precompiles into cryptographic functions such as EAP 1962 and things like this, and like verification of pairings and so on. So these things are not going to be supported, but they are required by very few applications. They're essentially required only by applications that are building zero knowledge proofs or that are building some advanced cryptography, and most DeFi smart contracts do not need that. So if you really need this kind of things, then you will have to wait. And if you wait a little, you will be actually much better off on Ziksync, because we will provide a lot of cryptographic primitives out of box that will be a lot cheaper than Ethereum. So cryptographic verification of recursive zero knowledge proof on Ziksync will be essentially not a lot more expensive than a normal transaction, a normal transfer. Now, the second class of operations is some specific things that are a little harder to, like, they are just require more work to be added, such as catch-up hashes, which is the native Ethereum hash, and EC recover. and a couple of things like this also that I listed in our blog post. So they're just not going to be supported in the first version. All invocations of Kchuck will be replaced with invocations to a different, what we call an algebraic hash function. So if your program only uses hashes internally, it won't be affected. If your contract needs to do some hashes external and verify them in the contract, then it will be a problem that you will have to wait for in those cases. And the same applies if you need to verify Ethereum signatures when your users sign something externally, and you have to verify them in your contract. So this won't be supported in the first version. Not many contracts use this, but those who do, we just like, they have to wait a little.
And for the specifically for the Kchuck part, the algebraic function will produce exactly the same hash result, right, in terms of specification of that.
Of course, like all non-algebraic hash functions such as SHA-256, Kchuck will just work exactly as specified and produce the same hashes as on Ethereum. And we will support all of them. Like the difficulty is we already support Kchuck and SHA-256. For signatures, for example, you can sign, you will not need a special signer. You will be able to use your MetaMask or any other wallet to submit transactions to Ziksync. The challenge we have is with variable hash function. When you make a hash of variable length, it just like it requires to add an additional thing like precompiles for Ziksync. And this is just a little more work, so we have to wait till this work is done.
Got it. Now let's switch our topic a little bit. I think on this grand level, we have this Ziggy rollup architecture, but nowadays I think increasingly popular people are talking about Validium, or even the combination of the two called Validium. So you guys have also worked out Ziggy Porter. So I think people understand the main differences, right, in terms of data availability and the guarantees at this moment, or even the stronger guarantee that will be possible once Ethereum provides like a data availability layer. But my question is around whether developers need to be aware of such differences and how they are supposed to divide their logic between these two architectures. Or do they need to do anything at all where there be some tools to help them separate the logic and data across these two architectures?
So developers actually do not need to be aware of anything, because from the point of view of Ziksync, it's the same system. You have two different account types, but in the system, like, they are completely indistinguishable from one another. You can interact from one account with the other. You can make calls that span across multiple smart contracts that are located in different addresses, and interact with user addresses in like both Ziksync and Ziggy Rollup and Ziggy Porter parts. You will not see any differences except in the cost of transaction, which will be different, but it will be on the validator level. The users will decide what account type they want to use. So as a developer, you don't worry about this. The users will just like decide, do I want to take the maximum security and pay slightly more transaction fees and use a Ziggy Rollup account type, or do I prefer very low cost transactions like on the side chain, and I'm willing to take some security trade-offs, and then I'm going for Ziggy Porter accounts, and I just pay 1 cent for every transaction. There will be ways to optimize your smart contract to take take advantages of this approach, but they're going to be purely optional. So like we will have a special guide how to construct your smart contract in such a way that like to reduce transaction costs for users on the Ziggy Porter side, but it's completely optional. If you don't do anything, if you just take your existing code, it will work without any modifications, without need to re-audit it.
So it sounds like for developers, you only need to develop for one platform and just have that deployed once, and yes, automatically it can be used for both deployments, right? The rollout.
Because it is one platform. It's just one platform with two different account types.
Got it. And I think we could probably imagine either end users will make the choice, or more likely some of the user-facing applications or front end will help users make such choices.
Exactly.
Got it. And what's your personal estimation on this? Like, eventually, let's say 1 or 2 years down the road, what's the percentage between users choosing, or applications helping users choose the roll-up deployment versus the Ziggy port deployment?
That's a really good question. So in terms of deployment, all applications will be just deployed on this layer 2 system.
Right.
So the users can decide. And what the users will pick, I think that it will depend strongly on the prices, on gas prices. Personally, I think that the gas prices will go up, because I expect that we'll have a lot more adoption of Ethereum and blockchains in general once the system become more affordable for many people. So we'll have new waves of millions of new users who are coming in and starting to use DeFi and NFTs and all these things, and this will massively drive the prices up. I think it will be similar to how you have your bank account with savings accounts and current accounts. So you put most of your funds in the saving account, and you have like some disposable funds on your zero account, where you just make like daily transactions there, and like you're exposed to more risk of fraud because your credit card can be stolen, but like you don't have much limit there on the card. So I think it's going to be similar. Most of the value will be held in Ziggy rollup accounts. This is where the whales and big funds and big traders will hold, and most users will hold like all their like cold storage assets. But the casual activity will be done from Ziggy portal accounts, which are a lot cheaper.
Yeah, that sounds very practical. I think that's really a nice thing to do. And the beauty that one deployment can automatically serve two kinds of transactions or types of transactions. I think that will just make it adopted from day one. So I assume that's going to be the case for all applications deployed on Ziksync, right? You don't need to do anything else.
Yeah,
that's fantastic. So would you like to give any estimation in terms of, let's say, the latency and TPS of transactions on Ziksync once it goes live on mainnet? Is it still due in August, the mainnet launch?
So the testnet will be launched probably this month. We'll probably open it to the public this month, and the mainnet will depend on how mature the system is. So we don't commit to any specific dates, but it won't take too long. And in terms of TPS, the Ziggy rollup will have the limitations of Ethereum, so it will share the Ethereum block space with all the other rollups. So all the rollups will kind of compete for this space. And of course, Ziggy rollups are a lot better positioned because they require less on-chain data. So we'll have higher TPS. So let's say, like, if we utilized all of the Ethereum block space, we would be able to provide like something like 2,000, 3,000 transactions per second. It depends also on the transaction type. So like 3,000 transfers per second, but not all transactions are transfers. Some of transactions are some DeFi operations that take a lot more storage access, so you need to publish a lot more data for them. So they will be reducing the throughput. But we won't be able to take all of that because there are other applications and also other Ethereum users. So realistically, we'll be somewhere like thousands, hundreds of transactions per second. But on the Ziggy portal part, we don't have any limitations. So it can go up to the well, we do have limitations of the decentralized validator sets. We'll still have to run another consensus in layer 2 to decide on what goes in the block. And this is going to be the limiting factor, not the zero knowledge proof part, because it's important to have these transactions decentralized, not run by like some central server. So it will be similar. So yeah, to what like the best consensus mechanisms can support. Like if you look at Facebook Libra or some of the Ethereum killers, like the levels they can support. This is what you will get there. So like the limit is very high, but there's still a limit. And in terms of latency, as I said, from the UX point of view, the users will get the confirmations instantly. The finalization on Ethereum will take longer. It will take from minutes to hours, depending on the transaction load. The more transactions happen, the more checkpoints, the more frequent checkpoints we can introduce, which will be subject to decision of validators. But let's say if you have 1,000 transactions per second, there can be checkpoints every minute or every half a minute. But if in the beginning you have less than that, if you have dozens of transactions per second, or maybe like even less, then you have to wait for enough of transactions, like let's say 10,000 of transactions to be collected in the block before this block can be submitted to Ethereum.
And if I'm confident of my own infrastructure, I can also potentially run a node and then do my own validation, right? Then at least for my application and my liquidity, I can support almost instant settlement. Is that possible?
I would not say that this is possible, because just like in Ethereum, if you run your full node, you still depend on the miners to finalize the transactions.
I see.
It's not like an optimistic rollup. With Ziggy rollup, you fully rely on the security of Ethereum. So you don't have to run your full node or like verification node to be sure that your transactions are final or anything. But the finalization, the checkpoint on Ethereum only happens after you have a big block, but you have a confirmation of your transaction before this block is collected. So like if you submit it, you get it in the same second. And like until the block is submitted to Ethereum, the miners could decide that they rearrange the transactions in this block, which will be visible to you, and you will be able to claim a compensation. So that's why I was saying that you will have an instant confirmation with economic security.
I see.
Sufficient for you to be confident this transaction will come through if it's a medium value transaction. But of course, if you're transferring $1 billion, you will wait for the checkpoint to be sure that it's final on Ethereum.
Right. So who funds the pool for potential compensation?
It will be done by the validators. So validators will act as block producers. They will the consensus of the validators, you can consider it to be a decentralized sequencer. So in the beginning, if the sequencer will be centralized, it will be just a server that accepts transactions and puts them in the block. And then users will have to trust the sequencer to like include their transaction. If they don't trust it, they have to wait for the checkpoint. But with multiple validators, it will be a consensus that collects the blocks, and then it appoints one of the validators to submit this block to Ethereum.
Got it.
And then, of course, the fees are covered by the user fees.
Got it. Yeah, thank you very much, Alex. I think, it has been very, very intriguing, I guess. A lot of, very cool technological stuff. Maybe we can just, talk about some of the high level, but also very important questions as well. So as I mentioned, Ziksync is just like a very fantastic, futuristic technology that's available today. And I feel it has all the strengths to be very competitive in the ecosystem. I'm wondering, what worries you? Is there anything that worries you? What could possibly go wrong to hinder the adoption of Ziksync and Ziggy Porter? Is there anything?
Sure, this is a great question. So I would say that if you have some black swan event, generally anywhere in the ecosystem, like if something goes wrong with layer 2, it will hinder the adoption of all of the layer 2 projects. And of course, if it happens to your project, then it's going to be the even more so. So it could be anything, that if there is some bug in the code, bug in smart contracts, some hug because of this, or maybe just reliability issues, that something goes wrong with consensus or with servers, system is down for some time, it will diminish the trust in these technologies. And all of the projects that are currently launching are new. So we have Ziksync version 1 running in production for 1 year. And it had a few downtimes. We never had any security incident. We are very, very careful about security, but you can never exclude that. Like the tail risk always remains. So like you have to be prepared for that. The way we prepare for it is we have a multi-layer defense strategy. How we protect the user funds. We wrote a blog post about this some time ago. It's on our web on our Medium blog, where we have like a kind of multi-factor protection. So before a transaction is included in the block, it has to be verified by the server and by the validators. Only if the transaction is valid, then we produce a zero knowledge proof. This is the second factor, because the smart contract will verify this proof. Then we have an upgrade mechanism. It's like if something is wrong with the system, we can introduce an upgrade and fix the bugs there. But this upgrade comes with a time lock. So if we, the team, become malicious and try to introduce any changes that will steal user funds or corrupt the state or do something illegitimate, the users always have a time window to exit. And this is a longer time window. This is not like 1 week. This is more than the window for optimistic rollups. But in certain situations, you need to act faster. Like I can imagine a situation where like there's some bug, and it's very, very unlikely in the case of Ziggy rollups that there's going to be any exploit to steal funds. But it's more likely that there's going to be something that will just stop the system, and the system becomes unavailable, like just downtime for some period of time, and you need to make an upgrade. So to accelerate these upgrades, we introduced a security council. We asked some very respected people from the community. We have 15 members of it to be available in case something goes wrong. They can accelerate the upgrade period. They cannot bring it down to 0. It will be still some, like depending on how many security council members vouch for this upgrade, the upgrade period will be reduced to 2 weeks or 1 week or 3 days, but we will have shorter response times for fixing things. So it's all laid down in the strategy. I encourage the viewers to take a look and read it.
Yeah, it sounds like you guys have really very carefully thought through, all the possible risks where things could potentially go wrong. And thank you for giving us this assurance that developers should feel very safe to build on Ziksync. So shall we spend maybe 10 or 15 minutes to quickly go through some of the questions raised by our participants, if
Absolutely.
you don't mind?
Happy to.
Yeah.
Sure.
So I think the first question is about hardware acceleration. I remember in one of your earlier videos, I heard you talking about that. Do you have any updates for us, like especially in proof generation? What are your thoughts or plans for hardware acceleration?
We will have an update very soon. So we have our hardware proof is fully functional now, and we're working to improve the performance, and we'll soon have something to publish.
Are you able to share whether it is more like ASIC or FPGA or kind of?
It's FPGA based.
I see.
Because we have cloud resources with FPGA instances available on demand, and we will be able to use it.
Got it. But the cost could be high, at least in the beginning.
No, the whole point of hardware acceleration is reducing the cost.
Okay. But sometimes when it goes to mass production, ASIC can even give you better cost saving. Is that something you're considering eventually?
This is true, but with regard to ASICs, FPGAs are actually quite efficient for this kind of task. Because what we're doing there are some specific mathematical operations which are called multi-exponentiation and the Fourier transformation, and both of them depend on memory strongly, and you can't really accelerate memory much with ASICs. So like the benefits of ASICs will be maybe 2x compared to FPGAs, but not more than that. So there is not much need to, like you won't get much benefit compared to FPGAs. And FPGAs are available already pretty widely. They can be reprogrammed and even available on demand in the cloud. So that's why we decided in favor of FPGAs.
That's right. And I think that will help the decentralization process of the validators as well, I suppose.
Yes, correct.
Yeah, thank you.
Because anyone can rent this FPGA instances and run them.
Yeah, I guess the community is looking forward to hearing more from you on this. The second question is about whether Ziksync is going to be compatible with sharding. I assume sharding means the Ethereum sharding eventually that's going to come. Is there any consideration in terms of compatibility?
So sharding should work out of box. We're still waiting for the final details of how sharding will exactly be implemented in ETH2, and it will still take some time for sharding to arrive. So first we'll have to launch proof of stake, and then the proof of stake has to prove that it's working fine, and then only sharding arrives. It depends on how exactly it's going to be implemented. To what extent will it benefit the applications? Can you access different shards simultaneously? Is the coordination asynchronous and so on? But the sharding is supposed to work. It just increase the throughput of the network and serve as this wider data availability bandwidth, which will simply lead to more capacity, like more transactions per second. So we don't have to plan any specific compatibility with sharding.
Okay, got it. Here is a quite long question. So the question asked about whether Ziksync still has a significant room for improving scalability once Ethereum itself, let's say layer 1, improves its scalability and gas price will be reduced. I think it's mainly asking about, let's say, after some key milestones of ETH2 have been achieved, how does that affect or not affect the scalability factor of Ziksync?
That won't affect it at all. So the only thing in ETH2 that can improve scalability of Ethereum itself is sharding. But as I said, we don't have exact details of how sharding will work. So most likely, the shards will become asynchronous, and you won't be able to have composability across shards, and this will not work for most DeFi applications. So this is why Vitalik announced the Ethereum-centric, rollup-centric Ethereum roadmap, where rollups will still fulfill the same function as they do in ETH1, also in ETH2, and will bring the same scalability factor. You will be just able to, you will multiply the throughput boost of rollups by the throughput boost of sharding.
Yeah, I think
we have to see exactly how it, like the devil is in the details.
Right.
We need to understand what exactly sharding will encompass, and then we can comment more on this.
Yeah, I mean the new roadmap, as you mentioned, a rollup centric ETH2 rollup. I think probably that will guarantee or tries best to guarantee that the rollups won't be affected, right? When sharding eventually comes to life.
Yeah.
Another question is about DDoS. It probably has something to do with the process of decentralization as well. So this person is curious about how is Ziksync going to be defending itself against DDoS attacks?
DDoS attacks on the network. So I mean, all blockchains have mechanisms against DDoS. In Ethereum, it's just paying the fees, so it's going to be very similar. So I don't see a different attack vector on Ziksync than what you have on Ethereum. And if it's not working on Ethereum, then why should like a different attack vector work on Ziksync? So there is no difference. It's the same approach.
Got it. There's a question about when EVM will be launched, but I heard in one of the earlier videos that you could possibly support EVM, but that's not the point, right? You don't have to. With Zinc, you can already support the functionalities of EVM. So I don't know whether you have anything to add to this particular question.
So maybe I can clarify how the system works exactly. So
right.
With EVM on Ethereum, you take your Solidity smart contracts and you compile them into EVM bytecode. With Ziksync, you take your Solidity code and you compile it into the Ziksync bytecode, the bytecode of this virtual machine. So like it's a different bytecode. It's very similar to how Optimism works. They have optimistic virtual machine, and you compile the Solidity into that. But for you as a developer, it doesn't make any difference. You just like what you do is you take your code and you compile it, and you get some bytecode which you deploy in the system. So it's a different bytecode, of course. It's optimized to be efficiently runnable in zero knowledge proofs, but it fulfills the same functions. It passes the same set of tests from Solidity and so on and so on.
Right. So it supports Solidity at the source code level, and I guess you guys don't have any immediate plan to do bytecode conversion at this stage because it doesn't.
We don't
benefits.
know. But if you use assembly in your Solidity smart contracts in your source code, the assembly will work just fine. So it will be actually like supported at the instruction level.
Got it. Now, I guess this is a common question. I mean, how does Ziksync compare with other layer 2s? But I guess there's already very good coverage. For example, Delphi Digital, did a debate. I think I would recommend any participants to, take a look at that as well. But for now, maybe you can just share one or two most important advice you have for developers who are trying to choose between different layer 2 solutions. What would be your advice?
Absolutely. So I'll answer the first question first. How Ziksync compares to other layer 2 solutions? I will say that I don't see anything but Ziggy rollups that will prevail in the long run. Like this is going to be a very strong statement, but I can explain why. The Ziggy rollups are the only layer 2 technology which is extendable with something like Ziggy Porter or Validium counterpart, where you have the best worlds of rollups and sidechains combined in the same system, atomically composable. No other layer 2s can do this. This is very, very important. This is important because we see the rise of the adoption on systems like Polygon and Binance Chain. And this clearly indicates that there is a whole class of users who care about the low fees first and foremost. They don't care about security as much as they care about the low fees. On the other hand, we see that most transactions still happen on Ethereum mainnet, which means that there are a lot of users who don't care about the high fees. What they want is highest degree of security, and they're going to prioritize the absolute highest degree of security. And of course, it has to be usable. You should not wait like 1 week to withdraw the funds. So you have these different systems optimized for different use cases, and Ziggy rollup is the only technology which can combine them together. Imagine that on Ethereum would be seamlessly interoperable, that you had users from Polygon or Binance Chain who can interact with Uniswap on Ethereum in the same transaction. So like they can make a transaction that goes to Uniswap and to Aave and to other protocols and then bring all the funds back to their account, and they are paying the low fees of Polygon. It's not possible. With the two systems, you have to like first move your funds from one to another. It takes some time, and then you can make trades, and it's expensive. Then you move them back, and it's expensive. It takes some time again. But with Ziksync, it's possible. You have accounts on the Ziggy Porter side. They're super cheap. You have accounts on the Ziggy rollup side. They are as secure as Ethereum itself. They have the highest degree of security, and they're completely transparent to each other. So this is why I believe the Ziggy rollups will absolutely prevail. Like there is no way that anything else will be there long term. So there will be other Ziggy rollups, of course. So other projects are working on this. We have Starkware with Cairo, We have other newer projects that are working on Ziggy rollup technology. I think no one is as close as Ziksync Starkware at this point. Like everyone else is far behind. But Starkware is making emphasis on Cairo. They are not doing as much Ethereum compatibility, so it will be a question of like, do you need Solidity and EVM compatibility, and you want to reuse existing applications, and you want to be in the ecosystem of projects who will migrate to the system from Ethereum, because they don't want to re-audit the code, they have extensive code base, they just want to use the same projects there? Or are you comfortable with building an application from scratch in a different language and like start it in a completely new ecosystem? So this will be your choice. If you care about like the ultimate performance and like you prefer this programming language over Solidity, maybe because you like Python, or again, the syntax of Cairo is more similar to that, then you can go for this. But if you want to remain in the ecosystem and you want to interact with Uniswap, Avi, Compound, Curve Balancer, like all the existing projects that already committed to remaining in the Solidity ecosystem, then you might be better served by Ziksync.
Got it. It sounds like at least something like Ziksync has this inbuilt native capability of interoperability even across different chain ecosystems. So that sounds like really something very beautiful to have.
Absolutely.
Got it. Let me wrap today's session up by asking just one last question. I think this is also related to what we just discussed. So the question is about whether you see Ziksync going to launch different rollups. Some might be more suitable for, let's say, streaming, some more suitable for data intensive computation, some might be for other kinds of applications. Or you are seeing just one Ziksync, behind the scene, you have a rollup, you have a Ziggy portal, but it's just one thing. Which way do you envision to be the case?
We definitely focus on one thing. Mm-hmm. We're not gonna get any distractions. We're gonna build the Ziksync with a single system, Solidity support, optimized for DeFi, NFTs, and these use cases. So we want to bring DeFi to the masses. Our mission as a project is to bring public decentralized blockchains to mainstream adoption, to connect the mainstream users with these technologies. And we're just going to focus heavily on this.
Got it. That sounds wonderful. Thank you very much, Alex. It's been a very, very, I guess, inspiring session. And for everyone watching our session, I hope you enjoyed the session as much as I did. That's all. Thank you, everyone.
Thank you, and thanks to all the watchers. It was a pleasure.